Okay? And once we've done that, then we can just add 10 to both sides. Is it okay if I show my work like that? Okay. Yeah, so 5x equals 108. And then I'm going to divide both sides by 5. And this was what I was telling you guys was 108 over 5 doesn't reduce, right? So that's a perfectly fine answer right there. I mean, you know, sometimes in the book it might ask you for a decimal answer, or there may be a story problem where a decimal answer makes more sense, but this is fine for now. Okay, so this one I just wanted you guys to think about and think if there was some way you could do this. So I'm telling you the two triangles are similar, we said. That's what this little squiggly line means. It means they're the same shape but not the same size. But it does mean that their sides are proportional. So however much bigger 10 is than 3, can I just hit that way? That's the same deal with the x and the 17. Whatever I need to multiply 3 by to make 10, I need to multiply x by that same number, and it'll give me the 17. So, I drew it this way on purpose because, look, the ratio of x over 3, this relationship between the x and the 3, is going to equal 17 over 10. That same relationship is going to hold true. Okay? And we could also do it another way. We could say the relationship between x and 17 is going to equal the same relationship as the 3 and the 10. Or x to 17 equals 3 to 10. But you'll notice whether I go x over 3 equals 17 over 10 or x over 17 equals 3 over 10, look what happens when I cross multiply. 10x equals 41? 51. Okay. Divide both sides by 10. And I guess 51 over 10, 5 and 1/10, 5.1, however you want to say it. And you'll notice here, do you see how it's the same thing? See how it's still x times 10 and 3 times 71 is 51? Or 3 times 17 is 51? So it'll work either way. We're just going to kind of keep hitting those a little bit each day until you're good at them. Okay, so slope. We don't want to graph 2 points every time in order to find the slope and count them, do we? Why not?
Long time.
It takes a long time, right? Especially if the numbers are big, right?
And drawing graphs aside too.
So we're going to do our formula. And you'll notice that the formula I have written right here, it's different than I have up here, isn't it? Here I have y sub 2 minus y sub 1, x sub 2 minus x sub 1. And this is what you'll usually see if you look it up. I'm not really sure why that is, but it doesn't matter. It doesn't matter which point is point 1 and which point is point 2. It doesn't matter which direction you go. You're going to get the same answer. You just have to be consistent, okay? And I'll show you what I mean here. So when I normally do this, I would just say, okay, 4 subtract 6. Did you guys notice I put the subtraction symbol down before I looked over here? Okay, so I have y minus y. Is that what I have on the top? Kylie, why do you look confused?
Because the 4 is not a y, it's not.
Okay, so it's y subtract y. It's got to be -2 here, doesn't it? Okay, so it's got to be y subtract y on the top. And on the bottom, x subtract x. So I put x subtract, and then I looked over here, and that's a negative. So I have to subtract -3. So I get both those negatives. So I always write this one down, and then I look to see what the other value is, and if it's a negative, I put that down too. And I write it down so I can see the difference between my subtraction symbol and my negative symbol too. So on the top we have -2 subtract 8. On the bottom we have 4 plus 3. So this one is down 8 over 7. Okay? Now, I'm going to do it again. but I'm gonna go the other direction. So this time I'm gonna go this direction. So I'm gonna take y sub 2, that's the second point's y, subtract y sub 1, which is negative 2, and on the bottom I'm going to take x sub 2, which is negative 3, and I'm going to subtract x sub 1, which is 4. I end up with a positive 8 on top, a negative 7 on the bottom, and is that the way we want to think of our answer?
No, you leave the negative up to the
Right, we're just going to put the negative on top. So do we still end up with down 8 over 7?
Yeah.
Right, down 8 to the right 7. So it doesn't matter which direction you go, you're going to end up with the same slope. Okay, so this one. Oh, are we ready? Okay. Ryan, what goes on top?
The y.
Okay, so just tell me what to write.
6 minus
6 subtract negative 4. Luke, what goes on the bottom?
7, negative 7 subtract 0.
Okay. So we end up with positive 10 over negative 7, and don't leave it that way, right? Okay, this is negative. We want to think of the top number as the negative. So this one's down 10 to the right 7. So whenever we think of the slope, we think of up or down, okay? And then we always think of to the right. To the right, to the right. Isn't that how that goes? I think there's a song about slope. Like, isn't that funny? Anyway, there we go. Okay, so let's talk about your assignment. Most of you are getting close to this one, so let's all go to number 29 and talk about it.
Oh, great idea.
And we're going to talk about making a linear model. If I can get my pen to work. A linear model is simply a linear equation that models what's going on, that kind of describes what's happening. Okay? What's a great way to make money, guys? In fact, I would dare say it would be the #1 way to make a whole lot of money. Yeah? I'm hearing a lot of stuff. Okay? Let me just propose this one to you. Okay? Ready? Predict the future. Did you say that one, Jem?
No, I've got one.
I have a future prediction for you. You're going to get an N if you're masculine on. Oh, good job. Okay. Predicting the future. If I can predict the future, think about that.
Nobody would believe you.
Or
Yeah, they wouldn't have to believe me.
Wait, or find the biggest prime number.
Oh, and
No. Predict the future.
I still like that.
Predict the future.
And then you
Predict.
could, like-
If I could predict the dude who's going to actually find out what the prime number is.
just
Okay, I got
get
it.
him a sack.
Okay, so what does a linear model do for us? Well, when we can write an equation that's describing what's happening, okay, then we can make a prediction from that equation that tells us what's going to happen out in the future. Okay? And if we can know what's going to happen out in the future, well, we're going to make more money. Even if it's as simple as this. Let's say I own a bike store, and I'm down in Moab, I have a bike store, and I can look back over the past few seasons and I can see a trend. I can see every year over the past few seasons, I can see that the number of people wanting a certain item has been going steadily, constantly upward. Can I make a prediction based on that, on what's going to happen next year? I can. Okay? And can I make money off of that? What's going to happen if I have that item and no one else does? What's going to happen if everybody else doesn't order enough and they're out? Okay? But I still have some. Where's everyone going to go? Right. Okay? On the other hand, what's going to happen if I order something and then nobody wants it, right? Okay, so making predictions about the future, it's a thing, and it's not as simple as we want to make it sometimes. But let's take a look at number 29. We're going to talk about a linear model here and see if this will help. In 1960, the world record for the men's mile was 3.91 minutes, sorry. Guys, that's a point. That's a point. There's our time, 1960. X is always time, right?
Yeah.
In 1960, the record was 3.91 minutes. Amazing. But then in 1980, there's a second point. 1980, the record is 3.81. Wow. That's not much difference, is that? 20 years, they took 1/10 of a second for the record. Or 1/10 of a minute. What is 1/10 of a minute? You guys know a 60th of a minute. That's a second, right? So it's not 10 seconds. Not a big difference. We'll talk about it later. Okay, we got 2 points. With 2 points, can we come up with an equation possibly?
Yeah.
I think we might be able to. First of all, though, when did this problem begin?
1960.
I don't want to call it 1960. That's a big pain in the caboose. 0. At time 0, when this problem began, we were at 391. So what's this time going to be then?
1.
There you go. It's going to be 20.
Oh.
Okay, so there's our 2 points. And you'll notice that one of them is a special point. By saying 1960 is time 0,
Found our y-intercept.
there you go, we found our y-intercept. Couldn't have said it better myself, right? We know the y-intercept, so that's a good thing, right?
Yeah.
What else do we need?
X
The slope.
The slope. Well, to write the equation, we need the slope, right? Okay, so we know the y-intercept is 3.91. We can find the slope here. Now, does the decimal answer make sense this time?
Yeah.
Definitely. Okay, do it.
Okay.
0.1 over negative 20 doesn't make a lot of sense, does it?
It makes 0 sense.
Point what? What does it come out to?
That's not really a small number.
That is
0.1
what?
over 20.
Well, what's 0.1 divided by 20?
Oh.
Yeah.
I like 0.0 something.
Points. Are you all are holding the count? There. Okay. 0.005. There we go. So what that means is every year it's going down a little bit, isn't it? Not much. Tenths, hundredths, thousandths, 5/1000ths of a minute.
Wow.
If you take that number and multiply it by 60, it's only 0.3 seconds. Okay? So it's not going down much, is it? A little bit every year. But there we have it. We've got a y-intercept. We got a slope. I think we can write an equation. Y equals...
Out of curiosity, is that right? Still?
Okay, are you guys going to go
X.
negative 0.005 times x plus 3.91. So this is our initial one. Here's our rate of change.
Move the paper up.
X and y, is that going to work for us?
Yeah.
No.
No. What is x in this case?
Time.
Time. There you go. Time. What is y in this case?
Minutes, I think.
Minutes?
Oh, sorry.
Yeah, I think it's minutes.
Oh, okay.
Minutes, the record, I don't care. Whatever makes sense to you, but it's certainly not y. Okay, so this is a linear model. Okay, this is describing what's been happening, and based on this, we should be able to make predictions about what's going to happen out in the future. Like maybe what happens recently. What about in the year 2020? Oops. Do you think we could make a prediction about the world mile record in the year 2020 based on this linear model?
Yeah, add in 20 years and take a 10.
Okay, what number are we going to put in for T? How many years are we out from 1960?
Oh, yeah, we gotta put in like,
How many? Is it 80 years?
Yeah.
60 years?
yeah, 60 years.
Wait,
60 years.
60.
From 1960 to 2000, that's 40, and then 20 more years, right?
Yeah.
So all we got to do is put a 60 right here.
Uh-huh.
Do it. You got a calculator? What'd you come up with? What'd you come up with? 3.6. Okay, 3.61. I'll go with that. That's 3.61 minutes. Okay, I just looked it up. I just Googled it. 3 minutes, 43.13 seconds. So it's kind of hard to tell because this is 0.61 minutes and this is 43 seconds. Kind of hard to know what's going on there. But if we take 0.61 and multiply it by how many seconds in a minute? 60. That's 36 seconds about. Okay? So our prediction, this is actually 3 minutes, 36.6 seconds. The actual record isn't quite that good. But we're not that far off, are we? After 60 years, right? After 60 years. So what I want to kind of show you here is we can make a prediction. We can have an idea what we're going to be at. But then on the other hand, are we exactly right? No. Now if we had more data, like if we could look at it all the way up through the year 2000, from 1960 to 2000, and then make a linear model based on that for the next 20 years, we're going to be closer. So the further out into the future you're trying to make a prediction, the harder it's going to be to be really accurate. Okay? This is what a linear model is about. When you do number 30, it's quite a bit easier because it doesn't give you 2 points. A recording studio charges musicians an initial fee of $50 to record an album. Studio time costs an additional $75 per hour. That's not 2 different points. What is that? That's an initial amount and a slope, a rate of change, isn't it? Okay? So you can just write that equation, can't you? You can write that linear model right from there and then go. Okay, I'm going to give you about a half hour or 20 minutes, we'll see, to finish this up.
Wait, What's the number?